Yo, 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 yo. What's up, everybody? Welcome back. Today we are working on our collaborative Rube Goldberg machine, and today's topic is working on HTTP file upload, kind of. So the context is we're working on this collaborative Rube Goldberg machine. The idea is that we have these like chambers where balls will bounce around in these chambers. They'll all be like kind of like connected together, and each chamber is defined by some WebAssembly module. The idea is that people are able to like upload chambers, and these will all get run in like on one server to make like one big simulation, and it'll be kind of fun to look at. That's the idea. And so, in order to upload or in order for people to like submit these chambers, we need to have some way of accepting them and validating that they're sane in some way. So we need to make sure that they're like within some reasonable size limit, that they don't take up like infinite compute. And so yeah, that's the goal for today. Is like, can we make some sort of page where people can upload a chamber? We like take that chamber and we run it as part of our simulation. And yeah, so I think the course of action is somewhat along the lines of let's like add a page with like a simple little upload button. Probably we want to like name the chamber too. I'm imagining kind of like eventually you're gonna have like I uploaded like my chamber and it has like a windmill or something, right? And then I uploaded like another one called like Portal, and I can like see that in here, and like we can like maybe run, balls like come in here, balls go in here, and like maybe we'll like even show as like part of this page like a preview of the chamber running outside of the simulation. And then I think that like we'll want to be able to like maybe like do a little trash can that looks like a mushroom but it's supposed to be a trash can, like maybe delete it in some way. And so like I think that like probably naming them is useful for that in some way. So we'll probably add like a little upload form that's like name file. Simple. Then like we are gonna like press this upload button. Upload. We're gonna like click this, and that's gonna send something to our server. And certainly our server right now does not handle that correctly. Right, so once we make our little page, we upload some files. We should be able to like receive those files in some way. Once we have the file and name in memory, we're gonna have to like put it somewhere. So we have like no database or anything right now, so we'll probably have to like create some sort of like probably pull in SQLite and do some sort of like database slash storage of files. Like we will want like who uploaded it, what's its name, and where are we storing it on disk, stuff like that. And then we get to do some fun stuff like basically instruction counting. So we're probably gonna like want to like run a simulation and see how much compute it takes. And we'll probably approximate compute by number of instructions, because on our server eventually when we're running this thing, it's going to be like how do I say this? When we're running this thing, if we try to like validate compute via like time, it's going to be like really flaky depending on what else is running on the machine, because our machine is going to be super slow. So maybe we'll say like approximately this many instructions are allowed to be executed, and if you go over that, then like fuck off. Yeah, then maybe we'll make like that little like view page, an admin panel. So like people are going to submit these things, and then we're going to be able to like say, hey, I want to like accept this now. So our database is going to have like, is this thing like pending, or has like an admin, i.e., me, gone in and said like this one will be part of the simulation now. And then if we accept that, then we'll update the simulation list. Probably we won't get here, would be my guess. My guess is that we could get to here today. And maybe if everything goes like super good, we'll get through here. But we'll see. We'll see. I just realized that most people say SQLite wrong. I say SQLite, but it's SQLite. I mean, I don't know. Maybe I say it wrong. You could maybe it's Sklite. Right? Who fucking knows? I don't know. Don't ever listen to anything I say as like the correct answer for anything, because I just make it up as I go. Okay, let's fucking get into it. Let's get into it. Upload module. Okay. Okay. So I guess let's just for now, well, let's not like, I'm not going to worry about like linking to this thing from the main page, but I think probably have like a separate page for upload probably makes sense. So I'll just call this like upload HTML. CQLite. Oh yeah, CQLite is what some people say. Yeah, I've heard that. I've heard that. Okay. Doc type HTML. HTML lowercase? Maybe? I don't know. Head. uh, body. And hello world. Okay, so if we go here, I think that we probably want to run our server kind of like long term here in a separate window and have it monitor a directory to like get new files, because I think that that will be faster. Instead of having to like recompile and re-embed the resources into the binary every time. That's silly. There's no reason to do that. So I think they have like a www root thing, www root, which comes from source res, and this says like don't use the bundled resources, use whatever's on the disk. And so now if we go here, we should be able to go to upload HTML. We see our little hello world, and we say like now I'm something else, and hopefully refresh. Now something else. Okay, chilling. We have our dev set up. Okay. So I don't know how to like upload files. I think it's like you make like a form and then you add inputs, I think. Yes, this is what I want. So we're gonna say like, hey, we're gonna upload some shit. We might want to have like a heading. And here we'll say upload WASM module. I don't know. Doesn't fucking matter. And here on upload, we're gonna go to like upload. Maybe. And we are going to have the file of chamber, name chamber, and we're probably gonna have like a type. Is there like a string field type? Dude, it's crazy how fucking lost I am all the time here. Input ID. Where's like type text? I want text. Yeah. ID name, and the name is name. Okay, there we go. What's that look like? Yeah, okay, and then we probably want like labels. Label for is name, and then the label is name. How's that look? All right, cool. And then I guess we want like probably a little line break, and then do the same thing. Oh, what the fuck? This is wrong. This goes here. Then this goes file or chamber, I guess we called it. And this is the WASM chamber. Get rid of this, refresh. WASM chamber, and then we want a break here as well. Boom. No file selected. Okay, this looks like shit, but that's okay. I don't care. I was gonna say I'll style it later, but it's very likely that I just won't do that. But that's okay. Okay, so I wonder what happens when we submit this query. Okay, so we get upload to this, and I'm pretty sure that like to do file upload, this is wrong. No file. Oh, no file embedded. That's because I didn't actually click the button. Okay, so if I click this and we say, hey, let's upload a chamber. Let's see what the browser does. Zig out, bin. Simple. Okay, if I run this, no file. Okay, so this is fine. This is just saying, hey, we didn't find this thing. But I was under the impression that this is supposed to. After that HTML page, you can declare yourself full stack dev. Let's go! I've always found the term full stack dev very funny because it's very much like the top of the stack from my point of view. Like, you know, you have like, maybe like BIOS, right? And he does a bunch of stuff. And then let's say, okay, you have like the computer hardware, kind of. And then you have like drivers, right? And then you have like, you know, kernel, kind of. Then you have like user space. Then you have, on top of that, you build like server. And then on top of that, you build like your client. This has like been like my mental model of this thing. So being like the full stack is this stuff is like so funny to me. Especially because like the server itself is often like pretty like abstracted away as well. Like the full stack is like you're using like Python into Django or whatever, however you pronounce that. Full stack, but whose stack is the question, I guess. Yeah, I mean, like I'm probably missing some stuff in here too. But it's just funny because I came from like my first job was I shouldn't say my first job, but one of the jobs I worked the longest at was like a firmware. So I was kind of in like this area, and so the term like full stack dev, I thought was like very funny. Anyways, What was I doing? Okay, so I was under the impression when I looked up like file upload HTTP or something, I think I was seeing that it's supposed to come in as like form data. But maybe if I don't specify this, then it just doesn't upload the file. So what happens if I type this? Because like if what I see here is that it's trying to give these things as query parameters, but the query parameter for the chamber is just giving like the file name, which is like not a file. We need the file data to come, not the file name. That's useless to us. So let's see if I do this, if that changes the behavior at all. Where the fuck? Oh, my bad. Upload HTML, and then ASDF, and we browse to simple, and we hit upload. They does still give us query parameters, so it must just do both. But I don't actually know. But we'll see. Okay, let's implement this endpoint and kind of just see what happens, what we see on our side. Method equals post. Oh, that sounds really useful. Thank you. That is I'm pretty sure that that's it. Pretty sure. Let's try that again. Fuck. Upload HTML. Okay. Fuck. Oh god. ASDF, ASDF, browse, simple, submit. Oh, so now it's just fucking hanging. What's happening? Submit. Okay, so now like it doesn't look like our server is even like acknowledging this thing, which is kind of interesting. I would have expected us to like immediately 404. But we can start looking at the server side and see what's happening. We have the world's shittiest upload page. And now we can use this for testing the things that we actually care about, which is the server. Because I don't actually care about client stuff at all, really. Eventually I'll have to, but I don't want to yet. Because, you know, if I want people to use my website, it has to look pretty. But even then, do I really care if anybody but me uses it? Maybe not. Okay, so here, can we maybe see... Oh, failed to generate response, invalid path. Oh, so our fucking application is just broken. Right. So when we, if we try to handle something and we just like don't know what to do, instead of doing the same thing and returning like 404 or internal error, we just, drop the connection, baby. And I need to fix that eventually. I fixed that in some of our like little dummy apps, but I didn't fix it here. But that's okay. I don't care enough right now, but eventually I will have to fix that because that's really bad behavior. Okay, let's look at upload and see what we get. So can we maybe here just look at the headers of reader? So I think we have, what happens here? Oops. We store our transfer encoding content length. Okay, let's see what the content length is. So reader content length. Let's just see what we get. And I guess this is gonna have to be any because it's like an optional, and I don't really know. I don't want to like figure out how to print that thing. And then I guess let's return like a internal error or something just to like make sure that the other side gives up. So here we will say status internal server error. I guess we'll claim that it's empty HTML. That seems fine. And we'll rerun this thing and see what happens. We will rerun it. And let's look. Refresh, resend. So we still get nothing here, which is kind of interesting. I expected to get something. So can we maybe, are we going to the right spot? Upload, yeah. I guess we're gonna have to do some debugging. So first of all, I see like 0 logs. So can we maybe at the very least go to our reader and see if our reader is doing anything? So when we pull our HTTP connection, we are supposed to log an error if we fail here. It would be kind of interesting to see what state our thing is in. So maybe every time we go through this loop, we're just going to say std debug print polling HTTP connection in state any. There we go. And we will log self state. And I guess we don't need this like multi-window shit anymore because we are recompiling every time we do anything. So okay, resend. So we are pulling the connection in state read, and it looks like we kind of never finished the read state, which is interesting. We never get kicked out of it. Oh, but maybe No, we should. Yeah, so it looks like we read once, we loop back around, and what's supposed to happen is once we finish reading, we're supposed to go into this like wait state, and we're supposed to say to our caller like, "Hey, could you feed me like a response, please?" And that looks like it's not happening. So it'd be interesting maybe to run this in GDB. Can I run this in GDB without exposing the client secret? I'd rather not expose it. But it's also not the right in the world if I do. If I just do this, I think this is fine. Oh, get fucked, me. Okay, guys, promise that you won't do anything rude with my secret keys, please. I actually don't think there's much that you could do, but that is a little annoying. Leaked, yeah, it's not the end of the world. Thread apply all backtrace. Okay, so is our event loop doing anything right now? It looks like we have one thread that is made for like client authentication requests, so we don't have to worry about that one. That's not the one I care about. We have one thread that's doing like the simulation loop. Don't care about that one. We care about this like event loop one, and he's just sitting there in epoll wait. So somebody somewhere said, hey, I'm not in this loop anymore. So what we could do is we could maybe like breakpoint here. And we could then run this thing, refresh. And then can I say like finish? Okay. So I did something and we got a wood block. Okay. So finish. Got a print. No, it doesn't show. Yeah, so we got a wood block again. Finish. Or continue. So we just got a wood block and then didn't get any data, which is kind of surprising. That's not very useful to me. Can we maybe... let's do this. Var ret is equal to this. We can't really do that. Fuck! Stud debug print... Oh, here. Let's log... We'll at least log... Here, yeah, we can log this. Wood block. So here, if we would block, we say, well, please wake us up when there's more data. Otherwise, we can say, here is our return value, and we can log that as well. So returning this value, any. Hi there, hello. Hello. So hello. Okay. So we probably don't need GDB anymore. And he doesn't like this because 321. Oh, because I have to actually return the return. You have to return the return for it to be returned. That is true, and will always be true. Okay, so when I refresh this, resend. So we just get wood blocks. So that's really interesting. So the connection is actually still open, which we can go to like cd proc p grep ball machine. I want to go to the file descriptors, and we should see like a TCP socket just like sitting there idle. This one, I'm pretty sure, is the one. File descriptor 12. I'm pretty sure. I just know that like we have some that sit open anyway. Like I don't really remember why. I think that like Nick's shell is leaving some sockets open, and they get like inherited by the child process or something silly like that. But yeah, it does seem like we like just never finish this connection. So what the fuck is going on there? It could be that we're misreading how much we're trying to read. So let's maybe look at this read loop, and maybe we're just doing something fucking stupid. Like, if we're like, hey, if the HTTP request is like, hey, we are giving you 100 bytes of data, and we read like 100 bytes, and then we're like, is there more? And then like we throw like, there's no more. We must have to wait for more data. And really, we're supposed to advance to the next state. That would be a problem. So let's maybe take a look at our read body. Okay, let's maybe go through here and we'll say reader state, and let's see what state we're in. I assume that we're going to see ourselves go from that like header read state to the body read state, and we never exit the body read state because we don't correctly flag ourselves as finished. That's my guess. That is my guess. Yeah, so we do go from like header to body. we could say we would block and we read some body and then we just never finish. So here, are you posting to upload or actually just slash? Where we're going right now doesn't matter yet because what happens is we kind of like parse the whole request, including the body, and then we ask our like handler to say like, okay, so we got this HTTP request. It was for this URL. Could you tell me what to return? And we're not even getting to the point where we're trying to return anything. We're just never finishing reading. Like from our perspective, we go like, hey, I'm reading the HTTP request. And then we just don't do anything ever because we like think it isn't finished. So we're probably making a mistake here. I guess what probably makes sense here is for us to look at maybe. Okay, so we read buffer length. Do we append to like some like total length count? We have our buffer is an array list. So probably we like push slices into the array list. Yeah. And then we check if we are greater than the expected size. Otherwise, if we're equal to the expected size, then we say finish. And this just isn't triggering probably. So maybe let's at least just say std debug print receive buff is now this long. Bytes long. And self buff len, boom. And then we can say at the beginning, we expect to receive some amount. Expected this many bytes coming in. Self content length. Okay. Let's see it. Fuck. No field name len in array list. Yeah. Fine. I get it. But it's annoying. It's items len. All right. Where do you get your ideas about projects? So this one stemmed from a while ago. I was working at this company and we made robots. Sorry, we didn't make robots. Sorry, we made neural networks. Well, we made a product, and the product's goal was you had like two cameras up in the sky, and they pointed some box full of like screws or something, and we want to like identify exactly where the screw is oriented, so that we can tell a robot to go pick it up at like the specific orientation. So you could like take the screw and like screw it into something with a robot, right? And it turns out that depending on like the shape of the part in the box, you're gonna have, wow, this maze is fucked, huh? It's like immediately getting to the end every time. Is it reset? I don't think it resets properly. So I think you're just gonna see like rapidly finish success. Rapid progress on the maze, whatever, it doesn't matter. Anyways, sorry, distracted. We're, what, 2 distractions deep right now? Okay, pop the stack, go back one. So we were, depending on the part in the box, how you want to select which one to pick up is like kind of different. And so we would like kind of bake in these like part selection strategies into our application. And at that point I was like, it would be really cool to be able to like embed like a script where each person can choose like their own part selection thing, right? And then I was like looking into this and I was like, well, how would it, like if I were to like embed some sort of scripting engine into my program, how would I do that? And then I was like looking around, I was like, okay, people embed like Lua and game engines and stuff, but I wouldn't really want to do that because like how would I know that like they're not going to do something like really fucked that I don't want them to do, blah 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 blah, right? And so I stumbled upon the idea of like it would be cool if WebAssembly modules could be like embedded in my like regular program. And so that's kind of like where this one stemmed from, is I was like was looking for an excuse to experiment with the idea of like WebAssembly on the server or like in a program or whatever. And then I also like, I occasionally I'll just like see things on the internet and I'll have like this like list of just like interesting things that I've run into. And so on that list was like physics simulations as well as like particle simulations, WebAssembly modules. And so all of those kind of like fit together for this project. But like generally it's like I either get like pissed off by things, I see something that I find interesting and I want to experiment with in some way, or no, those are probably the only 2 motivators. Yeah, so that's how this one happened. A lot of times I get pissed off about things. What happened to the Fuse file system that you're making? I used it for a bit and I never really quite finished it, and I stopped. I found like how to say this? That one was like I had a problem that I needed to solve, which was I felt like disorganized and stressed about like what's my next stream gonna be, and I just kind of solved that in a different way. So I just don't have a ticket tracker right now, which is not really great, but I might go back to that at some point if I feel like I need one again. What were we doing? I was refreshing this thing and I was trying to see. Okay, so we get a lot of data. So we say, I'm expecting 435130 bytes, and we get 435130. And so instead of us saying, like, okay, we're finished reading, we just say, like, could you give us more? And then we fail. So we just have a fucking bug in here. Just a fucking bug. It's probably that this is happening at the end of the loop. I would guess that if I take this exit condition and I put it... oh. Here, we like exit the loop and we just have to self state is equal to finished or something. Yeah. I guess what we do is we make this a while... maybe what makes more sense is we make this a while true loop and then we just move the exit condition up to the top. And then I think this handles it for us. I think that does everything we need to do. Let's see. That should fit. I think that fixes it. I think. But we'll see. Refresh. Resend. We do still get a wood block. Why the fuck? So why are we not exiting out of this? Right? Because like we should be here. Buff is now this long. And then maybe we'll say expected. Oh, is expected end size something fucking stupid? It is. It's the content length. Oh, this is just fucking stupid. Ah, fuck me. Okay. So this is just this is a bug. Okay, so at some point we have this like buffer, right? And we have like HTTP request comes in, and as it comes in, we fill up this buffer. So we have like HTTP request for like this thing and like, you know, cookies and like header, like what else is in the thing? Content length. Right? And then you get like an empty line and then like the body starts. And I used to just kind of put all of this stuff into the same buffer. But at some point I split it up so that we like read the header first, take this stuff out, stick it in like another buffer over here, and then reset this buffer to read the body. And so here I was just, this is still using the expectation that this buffer is going to be there, and it's just fucking wrong. So we just delete all this, and expected end size now just becomes CL. Boom, boom. Content length. And that, hopefully, fixes our fucking bug. If you want a more beautiful upload page... Hey, there we go. Okay, so we read our whole thing. That's good. We've made progress. Oh, look, it's so much prettier. Is this just like a little CSS? Yeah, just a little CSS. Very fancy. I will... what? Slurp that up later. For now, I won't think about it. I think there's like a chance that I'll just pull in some like one of those like classless CSS frameworks. I use this one often. So I might just like yoink this and still see if I think it's still shit after I do this. But we'll see. Okay, so we now have a request body to look at, and we can look at it. And let's actually do that. So when we finish reading this thing, now in our server, we should get to the point where we look at the header and we say, we put something in this like upload URL. And we should be able to say like, oh, here we like wrote the content link, so let's just see if that happens still. Okay, so you refresh, resend. Content length here. Yeah, okay, so we do get into this part and we have to actually do something with that. Let's maybe just print the body. This is probably gonna fuck up my terminal, probably. But let's just see what it looks like. Reader buff items. There we go. Let's just see what it looks like. Refresh, resend. Okay, so there's a lot of garbage. This is probably the actual content of the WebAssembly module. Fuck. And okay, here we go. So we get this like a bunch of dashes followed by something, then a header that this is form data, then this is the name of the thing. So this is just exactly what I punched into the name slot. Then we get like this thing, and he tells us the file name as well as like the name of the thing the content type, double new line again, and then this is just the content of the thing. So I assume I was looking. This is like the multi-part upload thing. So I think that there's like an RFC for this, and I think that when I was looking at this, they said somewhere that that things the like starting with a dash is expected. Maybe we should print the header as well. Actually, let's print the header as well, because there might be some clues in here about it might say like what the separator is and stuff, but I think it's like they basically say separator, headers, data, and they do that a few times, and I'm just not sure, like, what if my data happen to contain like the separator is like the one thing that I'm not really clear on right now. Fuck. Okay, can we run this? Oh god. Reset. Fuck. Quit. Reset. Can we do something like run this through less? Then when we refresh here, hopefully I can go back to the top. No, everything is coming from fucking standard error. Fuck, get me out of here. 2 and 1. So that standard error goes to standard out so that it gets redirected to less so that we can see it here. Okay. Okay. So what does this header have in it? He says multi-part for data. So here's the boundary. Okay. So here, they define this string. A bunch of dashes followed by 17199802664, and I guess the thought is that this, I've uploaded some binary data. I would hope that basically Firefox is like looking at the data and being like, I'm gonna generate these dashes in this random number, and then I'll just check that I can't find that thing in the binary data. Otherwise, I have to regenerate. And like, I guess like probably the fact that this is like a random number is like a really good like collision avoider. Yeah, okay. So without reading any specifications or like thinking very hard, I think that we look at the header, we look for the content type field, we validate that it's multi-part form data, and then we look for this boundary key. I guess like we need, like, I'm not really sure that we can guarantee that this is going to be of this form. We are very good at not thinking very hard here. Yeah, what we always say, do first, think never. That's the mantra. Okay, so probably the steps are look at the content type field, check that it's multi-part form data. Otherwise, we fail because we don't know how to do anything else. We probably split by semicolon. And then once we split by semicolon, we look for something of the form key equals value. Because I don't know if like maybe like other things can be injected in here. I don't fucking know, right? We're kind of lucky here in that our web server doesn't have to be generic and handle everything. It only has to handle our specific website. Ideally, it handles our specific website on any browser, right? But we can maybe like assume that our HTML won't generate requests that aren't a certain way. Maybe we can assume that. So we might even be able to be like, we could maybe get away with just like hard checking for multi-part form data boundary equals. Like we could maybe get away with that, maybe. I think I will also assume that if we trim the value, right, so that we like it's like if there's like white space in the end, I think I will assume that that's okay. And then we go to the body and we split by this separator. Then we parse, once we find the separator, we walk forwards until we find a double new line. And then we have stuff in there. And then again, we have this like semicolon split like thing in here that we have to walk. Yeah, okay. Sure. We can make that work. Okay. So I was right in that this is like not trivial. Or like that this will take some amount of time. Okay, so probably what makes sense is for us to like maybe make like a multi-part parser of some form. And this thing is probably going to like, his output is going to be, we could maybe make this like an iterator, or we could store a key value list in here. So we could like in here, could do memtrim with nr. Yeah, I think that's what I'll probably end up doing. That's probably what I'll end up doing. So I think that probably I'll do a lookup. So we'll call this like for like elms, I guess. I don't know. It's like a stud. I think there's a string hash map, and his value is going to be a const u8 slice. So we're gonna basically gonna have like pointers to keys, pointers to values, parts, multi-part parts. Yeah, that feels like it feels more correct, huh? And I guess we're gonna just write like function parse. I guess this isn't a multi-part parser anymore. This is just a multi-part. I guess this could be like just a like raw function, like free function. We don't need any state associated with this if we do it this way. And here we could say that our parsing takes in both the header buffer as well as the body buff. He's got a buff body. If we write buff before the thing instead of after, then we can make a joke about buff bodies. But I think I don't want to sacrifice the way that I read that to make that joke. So we will leave it like this. Okay. So here we're gonna say like multi-part form parse multi-part request. Yeah. Okay. And then because I think that we're not smart enough right now in our like header parser to like have arbitrary key value. So we're kind of right now wrapping, we're like using the standard library's header parser. And if I remember correctly, this thing doesn't give us the ability to like look at arbitrary fields. This just like has like the fields that they happen to care about. And so that's why here I'm taking in just like the raw header buffer, because we're going to have to find the thing that we care about. So here we're going to split on some sequence. So we're going to look at the header buffer, and we're going to look at basically things split by carriage return new line. This should give us each line of the thing. So we're going to call this like var header iterator is equal to this. From here, we're going to basically say header iter next to skip the first line, right? Because the first line is like, I think not useful. We could look. I'm pretty sure. Well, how do I? Maybe here we go into the network tab and we look at our request, our headers, and we look at the post. No, it doesn't really show it here, huh? Somewhere we had like header. Yeah, so the first line is like specific info, right? It's like I'm going to do this method to this target with this HTTP uversion. But then everything after that is key value that we can look at. So we skip first line, and then after that we have key values. So for header it next, we have some line. And I guess we're just looking for the line that starts with content type. Yeah. So if we have like a line that starts with content type, content type. And I guess we need to do like a case insensitive search. So it's std ASCII starts with ignores case. Hell yeah. What side pane were you in? I actually don't even remember what I just did. Oh, on that side pane you were in the headers and your router. Oh, I think that this shows headers, but I don't think this sends like, it says like poster. I was looking for like just like the raw buffer that it sends over. Right, like I can look at the raw. Oh, it does say raw here. Okay. I thought that if I clicked raw, it would only show the headers, but it does show it everything. This is what I was looking for. Perfect. Thank you. Okay, so if it starts with this, then we have our content type. So here we're gonna say like content type is maybe an optional const u8. No. Yeah. And it starts as null. And then here we say, hey, we found it. So we'll say a const content type key is equal to this, and then we can search for the content type key, and then we can advance the line by that much. Right, onwards. Except we have to be a little careful here that if the content type key len is greater than or equal to the line len, then we have fucked up. So I guess here we'll may have like a way to error out, and here we'll say return. I guess we could just like return null. Right? I guess like it depends on if we consider it an error that we couldn't parse this header. I think that's fine. Yeah, maybe we do consider an error. So invalid content type or something. Then we have, this is our content type opt is equal to this, and then we break. And then here we say const content type is equal to content type optional, or else return error no content type or something. I don't know. Yep. Then we can look at this thing. So what did we say? We said that there's like the multi-part form data, and then there's a semicolon. I think it was like, no, we can look. Form data. We can just kind of slap this here. Fuck. There. Yeah, so here. So here we are expecting multi-part form data. So we can split on the semicolon. So we can call this maybe a content type iterator is stood mem split scalar. We're splitting content type on the semicolon. This is probably going to be variable because we're going to be like while content type it next. I guess first we're going to say content type is equal fuck. Content type content type content type That's so stupid, but it is kind of right. Like this is like kind of like the mime type, I guess we call it mime type. That feels more reasonable. And this is just going to be the first thing. And then here we'll say return error no mime type if it's not there. Otherwise, then we're going to say if the mime type is not what we expect. So mime type, and this has to be ASCII equal ignore case. I guess I want this like trimmed as well, huh? Like this possible that this has like some padding around it. So this is gonna be like mime type trimmed is stood mem trim mime type with stood ASCII white space. Then we can check if the mime type. I guess I think I'm okay with doing like case sensitive matching here. I'm pretty sure if somebody yells the content type at me, multi-part form data, I'll tell them to go fuck themselves. I don't think that anybody should do that. I don't know if it's in spec. I don't really know what the spec is, but just going off what I think is reasonable, I think that's not reasonable. So here we'll say that it's not multi-part. It's fine. Yeah. What the fuck? If mime type trim, I want if mime type trim does not equal to multi-part form data. Okay. Otherwise, we're good to go. Then we look at the next thing. And for now, I don't think this is necessarily correct, but I'm going to assume that the only thing we can look at is the boundary. No, here's what we'll do. We'll do while content type it next. We have some thing, segment we'll call it, and we will split the segment at an equals. Right? Yeah. So U8 segment this segment iterator, and we'll say key is the next thing, or else return let's continue, I guess. Right, we might be seeing things that we don't other fields in here that we don't really care about. Not equal, that's a really good point. Good eye. And we'll do the same thing for val. And I guess actually this isn't what we want, huh? Because like, what if there is an equals in the value, right? I think in that case, we should allow that. So really what we should do is instead of doing this split scalar, we'll say like index of scalar. And we'll say a key end is this. Yes. Why is content type IT variable not const? Because this next command is going to like modify the internals of it, right? So you're probably gonna like, it's gonna have something like, you know, like parent or like thing I'm iterating is gonna be like, you know, some sort of slice, right? And then you're also going to have like where am I in the thing as a usize, right? And when you call the next function, it's going to modify this where am I in the thing, if that makes sense, right? Because like otherwise, if you called next over and over again, you would just get the same thing over and over again. So it has to be mutable. Okay, so here we have a key end, and then we'll just say val start is equal to key end plus 1. And if val start is greater than segment len, we have a fucking problem. Even if it's equal to it, we have a fucking problem. And so here we'll say return error no value. And I guess probably we should check the key length first because it'll be confusing if we like have no key and then we say that there's no value. That would be a confusing error message. So we should do the key start. Except we're not returning errors here. I forgot we were just continuing. So continue. We just continue. Yeah. Because there it's okay to have things that aren't key values. The real error is we don't see that boundary key. Okay, so we have key is segment from 0 to key end. And we have val is segment from val start onwards. Okay. And now we can start doing stuff like, this can be const, yeah, that makes sense. What do we do now? We say if the key key is boundary. What was it called? Boundary. Am I the only one who thinks that it's like this A shouldn't fucking be here? Boundary. I always say boundary, like that. Anyways, maybe it's just because I like slur my fucking words and I can't enunciate. But I've never ever pronounced that A in my life. Well, except for like 3 seconds ago when I was saying boundary like a fucking joke. But I mean, I've never seriously said that when I'm trying to say the word for real. Okay. So if we have this thing, then we have our boundary. So we can say that our boundary opt is a sum separator. And then here we just say boundary opt is equal to val, return. I guess here we could skip this. We could just do this. Yeah. And then break, I guess. And if we get to the end, we've iterated our whole thing and boundary opt is still null, we have a fucking problem. And we return error no boundary. And then we're kind of doing a lot in this one function. I will be clear that usually I would like probably later I'll go and I'll like split this out into its own function, and then I would probably split like all of this out into its own function. But I'm just gonna keep going for now because I feel like it. But here we're gonna say that like now that we have our boundary, we can walk the body and look for that boundary. Oh, fuck it. Okay, fine. You guys are such nags. Nobody said anything, but I'm still gonna do it. You guys, the guys in my head, they're saying you have to split things out. You have to. Okay. Fine. So, Oh, I don't want to. Never mind. I'm not. I'm just gonna keep going. I'm gonna keep going. So now we can look at the body. Now we can look at the body, which is body buff. And let's kind of see. I want to look at fuck. Okay. Unreachable, just so that it crashes. We're not actually calling this. We're judging you in silence. That's what I'm saying. Hello? Unreachable code? Fine. We'll put this here. The guys in your head that prevent you from spelling boundary, right? Exactly. Exactly. Okay, so in the body, we immediately start with boundary. So we can just immediately start a while loop. Yeah, that makes sense. So this is gonna be like while true. No, we're gonna say we can do a split iterator again. That's kind of fun. Yeah, stood mem split sequence. So we can look for in the body buffer this boundary followed by /r/n actually. But I guess we'll look for the boundary and then we will move forward by 2 bytes or assert that the next 2 bytes are rn, because otherwise you would have to like allocate a new buffer for this thing, and I don't really want to deal with that. So we'll say body iterator is this. Yeah, and we can say, well, body iterator next. We have split, I guess we'll call it, this split. And we'll say the first 2 bytes of this split should be /r/n. So if I understand this correctly. So if the split length is less than or equal to 2, less than 2, do we error out? I think so. No. Invalid split, I guess we'll call it. Then we will do the same thing where we'll say the first 2 bytes of this should be split 0 to 2 should be rn. And if this is not true, we have a fucking problem. So we'll just also return invalid split. Then we'll say const. Then we have to iterate the headers of the split. Or we could just ignore them for now. I kind of want to just ignore them for now to see if we can parse the whole thing. Because I think that if I try to parse these out, there's just introducing more room for error, and I want to see something work before I start refining. So let's go in here and we'll say we will just move forward until we see /r/n, which kind of means that we can ignore all of this. We can just say split stood mem index of, and we're looking at the split, and we're looking for /r/n. And we'll call this a content start is equal to this. And I guess we will just okay, for now, since I'm not parsing out the names, we can maybe make a return value, which is stood string hash map of constituates. We return ret at the end. Return ret. Return ret. Yes. And then what we'll just do is we'll like say like const var idx is a use size equal to 0, and we'll just name them by number right now until we parse out the names in a second. So we can just say idx plus equals 1. Maybe we defer this. We have to init this actually with a allocator, which means that this needs to take in an allocator. Holy fuck, this function's long. And then I guess here, if we fail out, we should de-init this guy. Yup. Yup. Yup, yup, yup. I guess we can just say, yeah, fuck this shit for now. And we get the content start. And then we just push the thing in. So ret put. We need to say that like const. We need to like make a string of the number. So idx string is equal to stood format buff print into some buffer. And we are going to print just the number and the IDX. I assume that there's some more efficient way of doing this, by the way. I just don't know what it is, and I'm never going to look it up, so that's all right. And let's just say that we have like 10 characters here. Surely we don't need more than that. A 10-digit number here would be crazy, right? We probably don't even need a 2-digit number. Okay, and then we should be able to like ret put. Oh fuck. Oh, this is so annoying. I guess we actually need to create a allocation for the string, or else it's going to try to like point the key of the hash back of the hash map back to this point on the stack, and then that point on the stack is going to be replaced with other shit and it's going to break. So we have to actually like allocate something here, which is fine. We will just leak memory for now because this is not going to stay here for long. So we can actually just alloc print here. This makes more sense. Yeah. And we will just be like, leak, baby. And we will put this thing with the content split from content start onwards. Yeah, sure. This gives us something. Then at the end we return ret, and so now if we call this function, it will probably not compile. But if it compiles, then we should be able to like log it and at least see something interesting. Like at least like the name should be one of the fields in there. So we can go back to our server, and where we handle this upload, we can just say HTTP parse this thing. I think that thing probably wasn't public. I probably did not make it public, so we'll make it public. And we want to pass in our allocator. We want to pass in our what else goes in this thing? Header buff and the body buffer. The buff body. Okay. And then we have elms or what is it? Multi-parts of parts that we decided to call it. This is failable, so we'll just write try, and then we can stood debug print. I'm hoping that there's some sort of fancy formatter on this thing, but there probably isn't, but we can check. If there's not, we'll just have to iterate it. It's fine. Okay, so now there's a bunch of compilers. Oh, only a few maybe? 477 on HTTP and HTTP.zig. 477. 477. Oh my god. Okay, so here he doesn't like this. Why? Const type of this thing is not indexable in our range. Oh, oops, I wrote 4 instead of while here. What's the next one? Starts with ignore case, expected 2 arguments, found 3 at 479. So maybe ASCII assumes U8s. Does, so you don't have to specify the type there. Content type op cannot assign to a constant. That makes sense. This should be a variable. Split scalar, expected 3 arguments, found 2. So here I need to write U8 for the type. Stood ASCII whitespace needs to be coerced into a slice, so we put a little ampersand on there. Content start is a optional type, so here we need to say or else. I think this is actually invalid, so here we'll say error and nobody once told me the world was gonna roll me. Here we need to try something at 551, so this is a failable thing because allocation might fail, which is fair. That's fair. Allocations can fail, and I like the mental model that they could. Okay. Error, no boundary. Error, no boundary. All right. So here we looked for the key of boundary. And so let's maybe std debug print each key and see how we fuck that up. Refresh, resend, boundary, key. Fuck, we forgot to trim it. Fine. Fine. We'll trim it. This is it stood mem trim a U8 key with stood ASCII white space. And then we use key trimmed instead of key fine. Fine. You're gonna be like that. Why does the code do what I ask it to? You know, that's fucking annoying. No body. No body once told me. So that's here. He didn't find a /r/n, which is kind of surprising, to be honest. Okay, instead of returning no body here, I'm just going to continue and see what happens. There's a chance that, like, maybe the last split doesn't have something or something like that. So, here we did get through this thing, and we do have 2 things in our hash map. It doesn't tell us what those are, but that's okay. I think that our expectation is that the first thing is the name and the second thing is the file because that's the order that they're in the HTML page. So here, if we were to just log, maybe in the server, if we went to upload and we logged, maybe parts get 0. And we logged this as a string. Hopefully this says like ASDF or something. Because I think that's what we put in the form. Hell fucking yeah, baby. Let's fucking go! Where are these dashes coming from? That might be a problem. I don't know what the fuck is going on there. Is that coming from this? Let's put this in quotes. I'm not sure if I'm just like left some other log kicking around. So let's just see. Let's make sure if I put that in quotes, it does what I expect it to. Key. Oh, interesting. This is like really fucked up actually. Okay, so 1, the body, the value here should not start at content start, I guess. Right, because we're actually trying to look for after the /r/n/r/n. Right, so this should be header end, and the content start is equal to header end plus 4. So that should at least get rid of like that like extra shit kicking around at the beginning of it. So here we refresh, we resend. Now at the very least we see like quote ASDF. Okay, first of all, let's fucking fix that key. It's fucking annoying that it's logging something where I didn't realize. I'm just gonna delete that log. Delete that log. We don't need it. Get that shit out of here. Okay. So now at the very least we have ASDF followed by some dashes, which I don't understand. Can we maybe look at what we sent? No payload for this request. What about this request? So here, the fact that there are 2 things at the end is very surprising, right? It's like it like went past the end of this. Right. So here we said, give me the whole split, and this split is split at the boundary. So like, what the fuck? Split is this. And I guess we put this in quotes so that we know. And Yeah, something about this doesn't feel right. Something does not feel right. Did boundary parse correctly? Maybe not. Yeah, it's possible. Resend. I'm such a fucking dumbass. Oh no, this is right. I don't know. It does look right. So split. What the fuck? Am I high? Split colon this thing, new line. Then I log the split, which is this part of the body split by the boundary. So why am I seeing the fucking word split in there? What the fuck is going on? Refresh. Refresh, resend. Oh, I'm an idiot. So split, we immediately see some header stuff. Oh, wait. Are there an extra 2 dashes at the start of each boundary? I think I saw somewhere when I was skimming the RFC that for multi-part form data that the forms are split by double dashes, and that is maybe double dashes plus a boundary, which would make this make sense, right? We can look at this request. Hello. Oh, here we go. So here we can look at this request, and we can look at the boundary key here. Copy this. So we have this, and then we have this as well. Oh, fuck me. Okay, copy, paste. It's fucking shorter. It's fucking shorter by 2 characters. Okay, so should we read the RFC? I would like to see. Somewhere in here. Each part may have an optional content type header, which defaults to text plain, blah, blah, blah. Car set parameter, car set field. Can we look at like boundary? Definition of boundary parameter. The parts are delimited with a boundary delimiter constructed using CRLF, the double dash, and the value of the boundary parameter. Yeah, okay. I think that is good enough for me. Okay, so I guess for now, we're gonna do like std format alloc print, and we'll call this real boundary. And this will be dash dash followed by the boundary parameter plus /r/n. It's probably the other way. Should the r/r/n come at the beginning as well? Probably, right? It's probably this. So we'll call this real boundary is this, and then we'll defer alloc free real boundary. We try this, and then here we write real boundary here. All right, let's see what that looks like. Let's see what that looks like. Refresh, baby. Okay, so now let's kind of get rid of this split log because it's just like fucking flooding my fucking terminal with shit that I don't want. Okay, refresh, resend. We do fucking see our ASDF name looks fucking good. Looks fucking good to me. Okay. Sick. So now we have, does this still happen? Header end is find /r/n. Yeah, it's fine, it's fine. Okay, so now we have to like parse out the name somewhere. So in this request, we have content disposition is the header we are looking for, and the name field is what we care about. So here, I guess we could say the header end is here. Here's the content start. And then we can kind of walk the header looking for content disposition. So you go split to header end. Split header is this, right? Right. And here we can do like split header iterator is a std mem split on sequence. And we're looking for the split header and /r/n. Boom. We are looking for, we'll call this the split header field, I guess we'll call it. And we are looking for something that starts with content disposition here. So it's like if what std ASCII starts with ignore case for split header field, we can maybe lowercase everything here. If it starts with this, then we have found our thing. So we are looking for name, I guess. And then here, we are basically searching for so the name is like quoted. And if there were quotes in the name, then we have to worry about quote escaping, except for the fact that we know that we don't care, like that our website will only be sending stuff with quotes in it. So we could just look for things between the quotes. We could look for. Well, I wonder. I'm actually a little bit curious now. No, that's fine. We'll finish the parsing and then we'll maybe loop back for checking if what happens if we shove a quote in the name of our field. I think it'll be fine. But we will see. Okay, so if we find this, then we are looking for split header field std mem index of. We are looking in this thing for name equals. So we'll say that the name start is name key is at this location. And if we don't find it, then we continue. I'd be hammering it with regexes. That makes a lot of sense. But I'm like, I guess why do I do it this way? I don't have a good reason. I feel like these are easier to reason about than regexes, like doing this type of parsing. But it is much more verbose and maybe not actually more easy to reason about. We're going to look for the name end is going to be, maybe we look at the split header field from name key onwards. And we are looking for a semicolon at the end of this. And then I guess we're saying const name start is equal to name key plus 1, 2, 3, 4, 5 plus a quote, so 6. And this is the name end. We'll call this like a plus. Shut up. Okay. You guys don't need to judge me too hard for this one. The names are hard. This is a fucking debug prototype code, okay? It'll get cleaned up later, and all of this stuff will get split into functions, and they'll get nice fancy little names, okay? But for now, I just want to see if we can parse the name out, you know? So we start by doing something and then we refine. We refine later. Off stream we refine. Okay. So now we should have a name, but like maybe there's something wrong here. So we should maybe like ensure that the name end is at least like larger than the name start and it's not 0. That's production code if I ever saw any. Yeah. So if name end is less than or equal to name start, we also continue. And then we should be able to say name is equal to split header field from name start to name end. Boom. And then we'll call this name optional. Follow the convention that I've set for myself. And then we'll say const name is equal to name opt, or else I guess it's an error. If there's any field with no name, we don't know what to fucking do with it. So then we don't need this like leak shit. And we can just write name here. Boom. And we don't have to like alloc that thing because we can just tie the names to their like the header buffer. And as long as the header buffer is alive for the duration of our hash map, then we're chilling. Then we are big chilling. Fuck. Wrote const somewhere that we shouldn't have. Bar. Probably here. All right. Oh, so we can't write down the name of the thing. So we should be able to now actually, we should get out in our server. We should be able to write, like, get the name out. So server Zig, when we look at our upload handler, and we should be able to look at the parts of name. And hopefully we see some like semi-reasonable data. Error, no name. Interesting. So we fucked up somewhere. And I guess what we should do is here we will kind of log all of the ways that we, first of all, we should break here. So here we'll say std debug print found content disposition. Yep. Here we'll say no name key here. Here we'll say no name end, and here we'll say name end too small. And this will give us a clue about where our bug is. We could write tests and stuff and like, you know, properly check things, but what if we just quickly threw out some fucking debugs? Found no name end. No name end. Interesting. Am I high? I'm pretty sure that the request has a Oh no, it doesn't. Okay, so I guess here it could have the semicolon, or it could just have nothing, and we have to go all the way to the end. Okay, so here this is or else name split header field len. There we go. There we go. Refresh, resend. Name end too small. Why? I guess here it would have made sense to print the name start name end. What did it what did it find? What did it find? 38 to 13. Whoa. Oh, because we are searching from the name key start, the start like offset by name key. So this actually has to have name key plus here probably. Fuck. Don't judge me too hard. It's fine. It's fine. It's fine. It's fine. All right. So here, index 74, length 43. What the fuck did I end up doing here? Okay, let's log this, I guess. And split header len is another number. How did I fuck this up so bad? How did I fuck this up so bad? So here we have 43 and we went from 38 to 74. What the fuck am I doing? That shouldn't even be possible, right? So we, like, the name start feels like it's in an okay spot. Name key plus 1, 2, 3, 4, 5, 6. I think that feels right. Then the name end, we look at the split header field. we start at name key and then we find for a semicolon. Otherwise, we go to the end. And then we plus equals name key because that's where we started searching from. And then the name end goes -1. So like the fact that name end ever ends up longer than split header field doesn't make sense to me. This feels like a bug. Like there's something that I just like. I mean, it is a bug, right? It's not working, but it's like, why? Semi was not found, so it's length. Yep. Thank you. You are right. There we go. We fucking found our key. Our thing. I think our thing is correctly populated now. I think. So we should have some form data now that has a name and a chamber field, I think is what our index upload HTML has in it. Upload HTML. He has a name and chamber. Okay, so now we can start looking at in our server Zig. How come it keeps going to the wrong fucking spot here? We're looking at upload here. So maybe we say we have the name, and maybe we write down we like kind of like save the chamber as name .wasm or something. Because then we can make sure that like the data that we have for the chamber itself matches what we uploaded, which would be very like a good double check there. So we will look for maybe the name. We won't even bother putting .wasm on it. Fuck it, doesn't really matter. And this can be try, and then we can say f dot no create file. Oh, does create file require like create options or something? It does, yeah. So now this should be a file, no information available. Am I fucking high? Feels like this should work. I don't know why. Oh, here we go. Then we will write out parts.getChamber. And then f close. There we go. So here we should see that we go to upload.html. We say uploaded wasm is the file name, and we browse and we upload simple. We submit the query. And now we should see uploaded wasm. And if we look at this thing and look at the chamber that we tried to upload, it was in Zig out bin. Was it simple? They are different, which is not good. Is that what we uploaded? It doesn't match anything. Oh, yeah. So uploaded is not any of those things. Maybe it has like some sort of like content encoding in it. What happens if we try to like run our ball machine with that chamber? Certainly it will just fail to load. Right? Segmentation fault? Yeah. Wow. That's actually very much not what I expected. It's like a very major bug. It does think that it's a WebAssembly module, which is interesting. Oh, it's got some extra shit at the end. Okay, wait, we're close. Can F close fail? I don't think so. I guess like probably it could fail if the file descriptor was bad, but Zig is just you know, saying I don't care. Like crash the fucking program. Okay, so why? I guess probably the /r/n at the end of the boundary is maybe not there on the last one. So maybe we look for this. And then immediately consume the first two bytes of it. So body iterator, we should then this stuff is good actually now. So here we'll say the split with new line is this. Then we say split with new line, and then we just say const split is you'll split with new line onwards. And then hopefully this still works. Oh, oops. Well, not with the fucking chamber that's segfaulting us. The fact that it's segfaulting us is also really bad. But okay, so we're seeing invalid split. Interesting. So that's coming from here. I'm almost certain that it's here that we're getting out. So, right, if I just did this, I think that we wouldn't see that same failure. Yeah, but I don't really understand why. Like, this feels like it should fail to me. I mean, this feels it should be fine. I don't understand. Stood debug print. Somebody told me there's a command I can use to get the escapes. Format escapes. I don't know where it was. It's fine. Stood debug print, and maybe we'll log it as any from split with new line 0 to 2. And we'll say split begin. Oh, maybe it's the last split. Split begin 1310 45 45. This is /r/n. Why is this one not? What the fuck? Maybe we can print out the split header. Something about this is just like fucked up. Split from 0 to header end. Like, what the fuck am I missing? Refresh, resend. So split begin here. Split header is this. Okay. Oh, here our split header has this shit in it. So the first one doesn't have the fucking double dash at the beginning. God damn it, man. Oh, that's so fucking annoying. Okay, so I think what's happening is we have like dash dash is our like separator plus boundary. But the first thing, like this only goes between, and this goes at the beginning. So we probably have to like fucking filter out the fucking boundary as well. So I guess we'll just fucking if there's a way to like split. Is there not one that like takes like multiple sequences to split over? If split with new line. If stood mem starts with, oh god, I hate everything. It's fine. It's fine. It's fine. It's fine. It's fine. var split. We'll call this split with new line and boundary. Split with new line is equal to split with new line and boundary, but this is actually a variable thing, and if it starts with boundary, then we say split with new line is equal to split with new line boundary len onwards. I'm gonna lose my mind. But that should fix it. That should fix it. Surely there's some better way to handle this, but I'll just do this for now. No, I don't want to refresh that. I want to refresh my web browser. Still no. Split header is this. Why? Oh, no, that's actually not. I was wrong. I'm an idiot. I am an idiot. It's this. The first one doesn't start with a /r/n. So we look for this. Let's try that. Fuck, I keep refreshing the fucking... Oh, here we go. Invalid split. Okay, we'll bring back this log. Let's see what's going on. What's going on? It's just an empty fucking split. Oh, interesting. Just ignore that for now. Split, split, split. Fuck. Okay, that feels like it might be right. That feels like it might be right. So let's maybe get rid of this split log again, because it's fucking long. Oopsies. Foreground, foreground. This goes here. There it goes. So let's see if... Aren't you meant to prefix it with the 2 extra dashes? I think I did. I think I did. So it looks like everything here is like maybe good. It looks like it kind of worked. And so if we look at the timestamp of... Okay. Okay, so we're not fucking good. Okay? Okay, so we have to shit. So we have to like where is that new where is it coming from? So it's because at the very end of this thing, we have to the last 2 characters of this thing might be a /r/n because the next boundary starts on a new line. So I guess we check that it's we take the new line off the beginning and the end. So wait, aren't we like unconditionally assuming that there's a new line at the beginning, which we decided wasn't true because it might not start with a new line? So this has to be like if we have to do like var split is equal to split with new line. And if split if we start with the new line, oh, but maybe this like header iterator kind of like handles that for us. So we actually don't have to pull off the new line at the beginning because the body is going to start at the right spot. So this is actually totally fine. But we do have to maybe pull off the end too. So, yeah, we're going to say const split is equal to split with new line from 0 to split with new line dot len -2. And we'll just say strip off last rn. And so I guess we should also say that this maybe we'll start with split is equal to split with new line, and if split with new line ends with rn, then we say split is equal to split with new line 0 to split with new line len minus 2. I don't fucking know, man. Maybe you want to generate a random file name in case people upload at the same time. They're gonna get like unique IDs in a database later, so I'm not really worried about it. Like this, like writing to the disk with the file name is like just like debug code, just to make sure that like the thing that we write out is what we uploaded. Okay. So ls-l, it's 35. We got an uploaded WASM. And let's compare that to what we think we'll upload. Boom, baby! Let's fucking go! Hell yeah. Okay. So we at least, in our specific case of uploading a file with Firefox with our really shitty parsing, we're getting the right thing. Right? Now, there's lots to argue here about like the fact that it's probably wrong in some ways. There's probably a lot of edge cases we're not handling, but I'm going to ignore those for now and deal with those off stream, and then you guys can just be like, oh, okay, well, you know, draw the rest of the fucking owl, you know? Holy, that's not good at all. An hour and 30. Okay. Let me think. Let me think. Okay, so what we have to do with that thing is we have to store it in a database with the user ID and the name, and we probably will like write the file with like a unique ID corresponding to somewhere in the database. That seems reasonable for now. And I guess it will go into like some database table of like unaccepted. And then the user can like look at things that they've uploaded or something. For now, maybe we'll just automatically accept everything. We'll auto accept everything for now. And because like we're not deployed yet. And what if we auto accept everything, then we can just add that to like, instead of specifying which chambers that we're running on the command line that we are right now, right? When I zig build, I pass in this like dash chamber flag, which says like run this thing. We could just pull whatever's in the database. And it's an hour 30 into stream. I think that's doable in an hour. Said the overconfident programmer every fucking time. So I think it's worth doing. Let's try it. So let's checkpoint. Famous last words, yeah. And I guess we need a database. I've never used the SQLite C API, actually. But I imagine it's not that bad. I've used this a lot of times. Rust QLite, I think it's called what it's called. And this just wraps the API, so how bad could it be? You know? How bad could it be? Well, okay, actually I'm pivoting. Let's start by just doing it in memory. So let's say load WASM module into memory and ignore and run. Right? So we can then do the database stuff tomorrow. And today we can just make sure, okay, we upload this module and we can see that it runs. Let's start there. So this is going to be yeah, load WASM module as a memory run. Sure. Okay, so that means that basically we're going to like ship this shit over to the simulation thread and ask it to like extend the list of simulations that it's running by 1. That seems reasonable to me. So right now, our simulations are kind of like hard coded at like launch. So here we kind of like in main, we say here are the chambers that we want to run. And then we have like an array list of simulations that we load from that list of paths. And then we pass the list of simulations as well as the paths that they came from into like our web server as well as into our like simulation thread. And so I guess we are going to have to like dynamically add them, which kind of means that like it's probably time to like spin out like an actual like app class, I guess I'll call it. Like usually the way I structure this stuff is I have like app, I call it, and then like server. And the server like talks to the app, and the server is in charge of like, you know, HTTP endpoint parsing, you know, like he's responsible for like transforming the data of the app into something that you can view over HTML or HTTP, whatever the fuck I don't know what the right word here is. But the app like will have like an API that's like, here are all the high level things that you can inject to me from HTML, from HTTP. I think that's more correct, from HTTP. And so I think it's time to do that, right? Because now one of the things that the server is going to be able to do is like add chamber. And kind of like right now, we just kind of had like these two concepts like merged together, right? Our like server thing, he's got like simulations that he can talk to and stuff. And then we just kind of had like a raw simulation loop running somewhere. So it's kind of like maybe this stuff. Authentication can still live in the server. Client ID can still live in the server. But maybe like this stuff just has to move into like an app. So let's run this. So we have an app, and he's got some chamber paths and some simulations. And I guess these chamber paths and simulations are probably going to be like, how to say this? Like dynamic, right? So these are going to be, instead of being like just slices, they're going to be array lists. And I should get in the habit of saying that chamber paths is this, so that I don't have to like worry about like mismatching the types later. Like this. And then this could be chamber paths, and this could be simulations. This is mad about all sorts of stuff, so we need to get just like some imports in here. Stood. App sig. So we have stood imported. We need to import the simulation from here. And is this all that we have in here for now? Probably. We're gonna have like some pub function in it, and he's gonna return app. So we have const app is equal to this. Boom. And we know that we're going to have some sort of API. Well, let's start. We're going to have to add chambers eventually, but for now, let's just start with trying to like keep feature parity with what we already have. So probably it makes sense though to have like a load chamber. And this is going to have like a path associated with it. We can assume that this is on disk for now. Later, I mean, when if they upload into memory and we don't save it somewhere, then it's kind of silly to assume that it's on the disk, especially because we don't need it to be. But for now, it's the way it is right now, so we're gonna keep it that way. Then that's probably going to be like this, and I guess we have support for a history. Like we like save the simulation state and reload it for if we're trying to reproduce physics bugs. I'm gonna ignore that for now. And it looks like we just have like simulation in it from history and simulation in it. So we actually don't need to do anything here. We can just call, this is just already a thing that exists. Yeah, so. Do we have a seed, chamber mod. Okay, I guess we'll just do this. Is the chamber mod a path here? Chamber mod is chamber mods items. Oh, so no. Okay, this isn't already this. So we have to like load the WebAssembly module, which we do up here. So this is this. This makes way more sense. Okay. And we have to have some allocator, I guess. Which we need to import. Yeah, okay. And then here we need to have some sort of loader. So where does that WASM loader come from? I see. I guess we will have one of these in our app. Why the fuck not? WASM loader is a WASM chamber WASM loader, I guess. WASM chamber WASM loader. Which means that we need to import that thing from here. Okay, then here maybe we take in self app. No, we are going to do this in initialization. So we will just take in the loader immediately. WASM loader is a WASM load chamber WASM loader. Okay, works for me. And then this is all fine. And then we just return the chamber. So what does this return? He returns a WASM chamber. Pointer. Right? Is it a pointer? No, not a pointer. Not a pointer. Okay. That is that. So then I guess on initialization, we're going to take in like the list of chamber paths like we do in main right now. So this is like args, chambers, chamber path. Yeah, okay, so we're going to take in chamber paths here, which is going to be a bunch of paths. So a list of characters, where a list of characters is a string. And I guess we're going to say, well, first we need to make our WASM loader like we did here. So this is going to, on failure, we delete this thing. This can be failed. We're probably going to need some sort of allocator in here as well. Alloc. Okay. And then once we get through here, we're going to iterate over those chamber paths. So this is going to be for chamber paths. And for each of those guys, we are going to load the chamber. Now, what do we want out of this thing? I guess we want a bunch of chambers as well as a bunch of simulations. So the simulations come from a chamber. So I think it's something like we have like the WASM file on disk. We like parse this thing and turn it into like a WASM mod. So this is like a compiled instance of this thing, but then like you can instantiate this thing multiple times, right, per chamber. So you kind of have like simulations. Wow, check out those M's. That looks nothing like an M. That's like barely even a line. But these guys can all like be instantiated from this thing, which probably means that like this simulation init of a chamber mod probably is referencing some memory. Oh, but anything that it's referencing memory-wise is like from the WASM loader. And all of these, does the WASM loader... Okay, so everything is heap allocated. So we don't have to worry about... I don't think we have to worry about the fact that like when we copy these things around, the structs are going to be moving around. I think any like references that things have to each other are all on the heap already. So I think that we're chilling. I think we're chilling. I don't think I have to worry too much. So we can just kind of do this like load chamber. So each of these is going to return a chamber. That's what doctors M. Yeah. Okay, so we're going to have like var chambers is, I guess, going to be, we're going to have like chambers here as well. Chamber mods. And I guess our chamber mods is going to be a array list of WASM chamber, WASM chamber. And then here is going to be chamber mods. This is going to be chamber mods. Initialized with alloc. And I actually think that I want these things to be unmanaged. because I'll already have my allocator sitting here, and so I can just like kind of keep track of that thing myself. We don't need to store it in each of these fucking things. Which means that kind of all of these guys can just kind of be like this. But they don't. We're gonna feed them in here, so they're not going to. But we can do this chamber mods like this. Boom. Okay, so for each of these guys, I guess we kind of want to do like init capacity with our allocator and the expected size. The expected size is chamber paths len. That way we're not going to be like reallocating as we go. Not that it fucking matters, but you know, why not? Why not? So then what? We load the chamber. So chamber mods append, try load chamber with our allocator and our WASM loader. And the path. Load chamber. I guess we have to do this. Const chamber is equal to this, and then error defer chamber dinit, then append the chamber, and then if it fails, we delete it. You know, the normal shit. Which kind of means that we need an error defer. I'll just fix me here. Right, we're gonna have to like loop over all the chambers and delete them, but I don't want to like write that code right now. Okay. Then we have our chamber modules, and for each module, we need an associated simulation. So here we are going to ignore the history stuff for now because I don't want to deal with it. And here we'll just say function init simulation is going to be this, whatever the fuck this is. So we return simulation CTX. This returns a simulation. This needs an allocator and a mod, which was a WASM chamber or something. Like this. Boom, boom, boom. We return this thing. Everything is happy. Happy, 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 happy. It's going to be a return like this. And then up here, we're going to say that like the chamber is this. The simulation comes from this thing, which was just the chamber. Then if these things succeed, then we can append the chamber and the simulation. So we need to make this thing like this. I guess both of these are failable as well. And we'll put fixmes on both of these things. And then here, if this fails, everything else goes away. And then if I guess we do try simulations, append simulation, and if this fails, then we actually have to pop the last thing, the thing we appended here, because probably whatever cleanup we do here will like conflict with whatever cleanup we do in here. So this just makes it so that we don't have to worry about that. Then we should have everything we care about here. We have simulations, we have chamber mods, we have chamber paths. I guess chamber paths is not an array list, huh? It's just a like a reference to some external shit that we handled in our argument parser. And so now we can just return our thing, our app. We are ready to go, almost. So this gets like this. Chamber paths is chamber paths. What else is in here? I guess we just copy paste all this shit, huh? Alec is Alec. WASM loader is WASM loader, I think. Invigorating shit. Okay. I think we're chilling. Think we are chilling, which means that in main, okay, this has to be public, that's public. These are private, that's fine. We go back to main, and we can now make an app. So we just kind of say const app is equal to app. We need an app imported. Okay. And we initialize with allocator, and it was just args chambers. Boom. So that kind of means that all of this shit goes away. Defer app dinit, which we need to make. So pub function dinit with self is an app. And that means we have to just go over all this shit, figure out what to delete. So we have self wasm loader dinit. That probably comes after self simulations dinit, which probably comes after for self simulations items. We need to sim dinit. No, there's no dinit on simulation. That's good to know. Or I should double check that. Fuck me. Simulation. It does look like no dinit because all of this stuff is kind of like static memory, actually, which is kind of interesting. Kind of nice. Good job, previous me. I like that. But the chambers probably have to be individually deinitialized. So for self chamber mods, mod dinit. No, really? Surely. Don't call me Shirley. Never gets old. Never ever gets old. There's definitely a dinit on that thing, so I don't know why it's fucking freaking out, but probably because this is say items, and maybe this has to be variables. So I have to write it like do by pointer. We delete the mods and self chamber mods dinit. So that's this one, this one, this one. We're chilling. We are chilling. I guess these guys need the allocator passed in because they're unmanaged, and that's probably fine. So here we should be able to app dinit. This should build, but it obviously doesn't. It never builds. 305. So this needs to come from app simulation saw items. And there's probably a few of these, so this also comes from inside the app now as well. And fuck. Okay, so this is in so app needs to be tried when we construct this guy. This could fail. And then it was complaining about something in here. FS, open path. So probably some non-try things here, which means that load chamber also has to be tried. But it is already. I just didn't write the API of the thing right. Okay, member function, we're expected 2 arguments. So on append, since these are unmanaged, we need to give it an allocator that we're working with. So alloc and alloc. And here we probably need to de-init with chamber is fine. This is fine. That's fine. Everything's fine. Simulation de-init, no field in whatever the fuck that thing is, because in 32, this thing has to be tried. This is failable. Everything is failable all the time. Expect to type this, found that, so this has to be variable, wherever the fuck that was at 29. Was it? What? This has to be, let's see. Another one here, same shit. Has to be variable to dinit, which maybe is like wrong. Maybe that's not correct, but it's fine. And then 39. This expected this, found that. Am I fucking high? Simulation is init simulation. Oh, I am an idiot. This is like this. Not a list of lists. 36. This needs to discard the thing that we're discarding. And main, we need to make this variable to allow dinit. Okay, compiles. Do we run? Hopefully we run still. So go back here. We run our normal shit. This is the wrong URL. It's index. Looks like it's still working. Chillin'. Okay. I don't like the fact that this is running in less all the time, so I'm just gonna run it once so that I have like it in my history for next time. Okay. So all of this was so that we could pass the app to our server and maybe start adding APIs on our app to like append new chambers. Right? So here, instead of taking in the chamber paths and simulations, let's just take in the app. Which means that we need an app. And then this becomes app equal to app, and then probably some shit's gonna go fucking awry. I guess maybe we can use trouble here. Nope, not hooked up. Fine. I didn't want to anyways. 323 in main. I knew you were trouble when you walked in. Dude, that, have you seen that, like, Taylor Swift trouble goat? This was, like, my favorite meme for a while. This was 2013 for you. It's so unbelievably stuck in my head forever. Okay. So probably everywhere where we used whatever the fuck that was, chamber. So this should be gone. Chamber paths. What didn't I replace this app? I did. Chamber paths should be replaced with the app. Simulations should be replaced with the app. Okay. No field name app in server. Did I not? Am I high? Oh, I only changed it in like the initializer, not in the actual member variables. So, okay. Self. So here I can probably do something like clever, like self server simulations is self server app simulations, and do the same for chamber paths. So here it's self-server chamber paths goes to self-app server app chamber paths, and that probably does it. Not quite. No field name len in this thing, so server 209. Oh, because it's all items. Fuck me. Okay. QQ, find the S, write items, hit next. All right, that did it. All right. Everything's still working, so we are chilling. Then what? All we need to do now is add an API to like add a simulation on the fly. So in our app class, maybe am I allowed to call them classes if there's no class keyword? Is it a class in Zig? I've been like trying to get myself to use the word object instead of class because I feel like it's like slightly more correct, right? Objects are like this generic instantiation of things, but like class, I don't know if like is class language specific? I don't fucking know. Okay. So let's call this like add chamber. Object reminds me of Java. Do not say that. sorry. You're right. You actually get to control the words that I say. Not only can you say, like, could you please not say this, but you instructing me actually makes me more likely to do it. Okay, so he's going to take in a probably like byte, like a not like the path to the thing, but just the thing itself, right? So this is probably going to be like this. Right? Just like some like raw shit. And does it need a name or anything right now? No. We should do that eventually, but for now, no. And so here we're just going to do something like, oh, fuck. Okay, before we do this actually, we need our like simulation thread to be kind of like part of this app now. So let's do that. So this is like run simulation, and we'll just kind of like yoinkies this shit and go over to our app and kind of like let me think. So like, do I want the model of this thing to be that the app and the server run on different threads, or do I want it to feel like the server owns the app and the app just happens to be doing some things on other threads? I think the app being like the simulation feels okay right now, but as this turns into like, what happens when we start adding in like a database? Right? Who, if the database is owned by the app, then like it doesn't really make sense for like app.run, but that's okay. So for now, we'll kind of model this in our heads as the app is just simulation state right now, and if the database could live in the server later, that's fine. I'll keep it that way. So this is going to take in self as app, and yeah, that's all he needs. So this is going to take self simulations, items. Self simulations items. This is like some shit to handle like loading from history. So I'll just leave this in here, even though we haven't like done this yet. And I'll probably just somewhere I should write a fix me actually. So here I'll write a fix me history, baby. Okay. This shutdown field, I guess, will come from self. So here we'll have a shutdown is a stood atomic value bool initialized with false. I guess it goes like this. Is this how you do this in this language? Probably. Dude, I will say, dude, it's so fucking sick that you can do this in this language. Like, I'm so used to after writing Rust that like this that you have to like runtime initialize this thing. But it's so sick that like your atomic value, while it is like this thing that is modified at runtime, it's like compile time value is like very known, and you don't have to call this like comp time init function. It's just like the init function happens to be compile time. You don't have to worry about it. It's so cool. It's so sick. I guess Rust probably has that too at this point, but shut the fuck up. Okay. Now the question is, well, first let's compile. Let's actually run this. So in our main loop, I guess we will say that this now, instead of running run simulation, this runs app run, and we will just pass in app here. Is this explicit type on that line redundant? I wasn't sure about that either. It might be. I'm honestly not sure. This is a little bit of like a fucky wucky API here, but I don't want to deal with it right now. But we should probably do something like fix me should maybe not access app shutdown directly. Maybe it can. Maybe that's fine. The Zig way of like structs just being data. Seems kind of maybe okay, but the field will know those must have type. I trust Two Step here. He seems to know Zig better than me, so I trust that he is correct here. Okay. So we spawn our app run thread. Everything should still be fine. Nothing should be broken. If we run our shit, we should see like a simulation and it's running okay. Okay. So now we are kind of like in a state now where our app, he can like now know that he's a thread safe thing. So we could say that we have a mutex and he's got a thread mutex is equal to this. And I guess just on each iteration of the loop, we will lock the mutex. Right, so we go here. And we sleep for some amount of time, and then we just kind of rip as much as we can. You could argue that maybe you should copy out the simulations and only lock the mutex a little bit, but I think it's probably fine. I'm not really too worried about it. So let's just keep the mutex locked for the whole section here. So self, maybe we'll be a little cheeky. We'll be a little cheeky and lock it here. Yeah, that's fine. We'll be a little cheeky. And then if somebody Well, we'll run that again. Why not? Why not? Refresh. Okay. Let's be a little cheeky and... Oh, we've done the little cheeky. Now we can do the function append chamber. And here we will take in the chamber. I guess we'll call it the like data. And I guess this is just going to be very similar to what we had down here. It's just this. Yeah, it's just this. So we don't have to do this like load chamber shit. This comes from the WASM loader. We load with our self allocator and the data. And then we say simulation is equal to init simulation given this chamber. So we have the allocator alloc in the chamber. Error defer simulation dinit. I forgot to write try here. This is a failable thing, so this has to be tryable. Then here we have to lock the mutex. You know, sometimes I get a little worried because the way I like do this stuff is like so non-linear. And so the fact that like I did this first and then later was like, oh, I guess I should lock this mutex, it makes me so worried that I'll miss stuff. And like maybe that's why I like a language like Rust so much, because like the idea that I just can't miss stuff is so appealing. But I also don't know how often it comes up that it's actually a problem. But it just does worry me that I wrote that in the wrong order. But whatever. Then I guess here I just append those things to the thing. So maybe all of this kind of feels like this error handling stuff is very duplicated. But so maybe it makes sense for this to be like a free function, right? Like how do I say this? This flow of like taking a chamber, appending it to the lists, and then popping them on certain failures, it feels like this should be abstracted. So fix me free function to dedupe with init. And then we should be chilling. Now, I think that we're going to have a problem here where the simulation actually expects to be at some specific time step. So here we're kind of expecting that all of our simulations are running in lockstep with each other, which means that we should just assign this guy like the time step that is equivalent to somebody else's time step. So we can do something like simulation nom steps taken is equal to self simulations items 0 nom steps taken, and then we just have to say if this is valid. There we go. That way, I don't think that we're gonna like fucking rail or CPU when somebody first uploads. I think. Yeah. So now in our server, we should just be able to like wherever the fuck we were handling that upload, just say like self app server app append chamber with this shit instead of writing it out to a file and then return okay. Maybe I would be like shocked if that worked. Error unit is ignored. Shut the fuck up. Which error unit out here? All right. So here, if we went to upload.html and we like browsed to get a new chamber, right? If we just ran platforms again, and then we submit, and then we go back to index, we should see 3 chambers running now. Instead, we see a fucking panic because somebody is still using some cached value somewhere. Server app chamber paths. Oh, we didn't append to chamber paths. Fuck me. Okay, so chamber paths does need to be an array list. Oh, interesting. Wait, this is fucked. Right. So in order to display the chamber on the client side, we try to get the WebAssembly module that is being used and like load it again. Like we send that to the server. Or sorry, we send that to the client so the client can instantiate it. Which means that if our thing is only in memory, we would either have to like store the data for each chamber here, or we can just write it to disk and then everything else just works probably. So I'm gonna do that. We're gonna write it to disk. So here we're gonna say chamber paths is a array list of paths. I think we're still okay for the API of this thing to be that like it takes in a data thing, and we'll just write it out here. So we can just do kind of like something like this. Self. We could like whoa, how can I hack it for now? I don't want to get like too crazy. We can create file that's just like chamber d index. Yeah. Stood f it, no, format alloc, print with our allocator. We make this new chamber. We'll put it in uploaded, I guess. And this gets the index. New chamber index. New chamber index starts at 0. Yup. And self new chamber index plus equals 1. File name is this. We create file f name with no options. We open this thing, which kind of means that this needs an error defer, because this stuff can fail now. This is a file, and we just write the data to file. And here we close the file after. Chillin'. Then we also need to write the file name to our chamber paths. So chamber paths dot append f name. And right now we're not going to worry about deallocating this, but fix me. Yeah. No, it's fine. We will. So we're going to go over all of our chamber paths. And we're going to self alloc free this path. And you know, it's kind of shit because like some of these things are static paths from that were like given to us by our command line argument parsing, but I'm just going to ignore that fact and kind of start by saying chamber paths equal to chamber paths dot, can I like init from slice? No, but we can do init capacity alloc and chamber paths len. And then we can just chamber paths append slice chamber paths, I think. And then I think that'll do it. We'll call this chamber paths in. And then we should be chilling. Fuck. No, wait. This is wrong. We need to go for p in chamber paths in. We need to duplicate the path so that when we free later, it's not freeing like the wrong fucking memory. So this should be append, this should be try, this should also be try, and then we should append alloc dupe p, and this should also be try. Which means that here we kind of need to do some sort of like error defer for each chamber. We need to like for each chamber in chamber paths items, what the fuck did I write here? Items. We need to like alloc free the path, and then at the end of this we chamber paths dinit with alloc. Okay. Oh, I guess I could have written fix me error defer like I did for the other ones, but you know, fuck it. Because that really this should be like split function to share with dinit, right? So we don't have to write this shit twice. And if like the format of the data changes, it like gets auto updated everywhere, right? Let's just go somewhere else. But for now, who gives a shit? Oh, I see. Oops. So this now has to come in as a const u8. And 39, he's mad because I need to give him an allocator. And this guy's also mad because I need to say that the path is made of u8s. Server Zig is now mad because this thing is variable. So he has an items field, and error union is ignored at 139 in app or something. 135, 139. I wasn't reading it. This one. And fuck me. This needs a self alloc. Boom. Okay. There's like a non-zero chance this works. So here we can go to upload HTML. We can upload some shit. It looks like that did something. But now we have all sorts of crazy shit going on here. So it looks like we actually have like Rust errors coming out of this because WasmTime, our like WebAssembly module, uses WASM, and it looks like it's failing to find the stuff we care about. Did we upload the wrong file and that just like fucked everything up? It's like a real possibility. Let's try this again. So ASDF, we browse this, we get simple WASM, submit query. No, that's definitely fucking shit up. So it would be nice maybe to run this into less again, so that when we resend this, we can then just here, where does it go wrong? Failed to generate response, file not found. Content type, application WASM. So our WasmTime thread is just like failing? I don't see any reason why this is like fucked up. So here we should at least go, if we look at our uploaded data. Hello, computer. Thank you. Could you hurry the fuck up? Oh my fucking god. Oh my god. Oh my god. Oh my god. Uploaded what? Oh! Do I need to make that folder? Uploaded. Yeah, it was here. Did this maybe fall the fuck over? Possible. And then it's possible that like my error cleanup here wasn't right in some way, shape, or form. Although I don't see why that would be the case. It looks like we did. Oh no. It could be that because I uploaded a module that's already uploaded, maybe we dinit something that it could be like WasmTime under the hood is like hashing these things, and it might go like, oh, I already have this one, so I'm not going to reinstantiate it, and then we deinitialize the chamber and unload it, and it fucks up the other modules. That's like a very possible thing. So maybe fix me check if WasmTime dedupe fucks ruins this, because I feel like that would explain it. So maybe then instead I'll zig. When I build and run, we just won't give it the simple chamber, and then there's no risk of that happening, just to see, right? There's a chance that like it's something else, but you know. So now we only have platforms, and we should upload simple, and did something. So can I upload simple with the name ASDF? Boom, baby! Let's fucking go! That's so sick. All right. So there's definitely some like edge cases to deal with there, but I will deal with those later because we are at 2 hours and 25 minutes, which is a little longer than I would have liked to go. But I think we made pretty good progress today. That's pretty sick. So what did we do? We Added this like world's shittiest upload UI, right? Where we added a little form and you punch in a name and a WASM chamber. This goes and get like posts to our Zig server. So we had to implement multi-part uploading on our Zig server side, which is pretty sweet. That seems to be working. We parse the parameters of this form into a map, and then we extract the chamber data from the map. We ensure that like the chamber data matches, blah blah blah, and then we refactored our like main thread so that it runs in this like application, and we can like ask the application to add more chambers as like at runtime, which is working great. Yeah. So thanks for watching, guys. If you like what you saw, I stream most days at around 2 o'clock Pacific time. We are right now working on this Rube Goldberg machine as like an excuse to explore like WebAssembly, physics, Zig web servers. We're having some fun. So the long-term vision is that eventually these will all be connected together, and this like upload UI will be tied to like a user account, and we'll have like some sort of like large machine, and we'll probably end up like replacing this like maze on the right with some sort of like following of like a specific ball. Is probably where it's going to go. There's a YouTube link in the Twitch description where you can like check out our projects organized by playlist. Some things are in here that are kind of interesting. Operating system, zlib implementation, QR code decoder, terminal emulator. These are all kind of fun. Neural network. Those are all kind of fun. So if you want to check those out, those are available. There's GitHub link in the Twitch description as well, where we have code for all of these projects. If you're on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi if you're online between 2 and 4 o'clock Pacific time. Like and subscribe, Twitch Prime, you know, all that normal shit. And then I think we'll say goodbye to YouTube and Twitch. Let's raid somebody.